Abstract factories. It's also worthwhile to be aware of the abstract factory pattern, which aims to encapsulate a group of individual factories with a common goal. So it's like grouping this creator uh, that has the common goal, kind of like in about face relating the related function. It separates the details of implementing a set of objects from their general usage. So it separates the locality and the generality of the code. So it allows you to abstract those factory. You can use an abstract factory when a system must be independent of how objects it creates are generated. So if you want like an independence, so another way to look at it is that you would generalize it if those implementation are different um, with how it is generated, or it needs to work with multiple types of objects. Right now, you understand what the code does, but you don't understand why the pattern exists in the first place. So factory still feels like a different way to call new. It's not a different way to call new. Factory is actually about something much deeper than object creation. First, what factory pattern is really solving? You're reading it as instead of new car, we call factory that create vehicle. That is the surface. The real problem is this. Programs often don't know what object they need at the place where they need it. That sentence is the entire factory pattern. So if the program like that calling that factory know what they need, they don't need like this automatic setup. So this like automatic object allows you to easily instantiate an object without even thinking about your local implementation. So it's like the default object that will be instantiated if you don't configure it locally. So a very real example in your LiveKit app, when a request hits /API/invite/create/API and then /API/waiting-room/admit and then /API/session-chat/messages. At that point, your system does not know yet. Is this a patient? Is this a doctor? Is this an admin? Is this a web hook bot? Is this a reconnecting participant? So you don't know those identities yet or the role or attached to those requests. But you still need some object that can authenticate, join room, send message, and moderate. So this object, kind of like a prototype or behavior, still needs to be able to assist those requests. So even though if you don't know yet, the code receiving the request cannot safely do new doctor session because you don't know the role yet, or because it does not yet know the type. This is precisely where factory exists. The deep essence, prototype answered, where does behavior live? Singleton answered, how many instances should exist? Factory answers, who decides what to create? So that's different. So basically, like, how would you, where would you attach? Another way of thinking about is that where would you attach that behavior? So I think that's clearer than who decides what to create. This is the missing piece in your mental model. Why constructors are a problem? Constructors assume the caller knows the type, like cons s equal new doctor session argument user. But, okay, so that new doctor session, let's say, are attached to those authenticate moderates and send message. The caller often does not know in real system. Only the system state knows, or like the actual state in the system. Example, if user dot role equal doctor dot dot dot, and then if token dot type equal dot guess. So you only know this at runtime. Like again, the system state, which is the that attached to the object at that time of execution. If every caller must understand these rules, your entire application becomes tightly coupled. So if the doctor basically needs to know or like understand those moderation can authenticate, send message, then those identity will be tightly coupled and uh, will violate the implementation and the interface law. Uh, so it like creates a lot of overhead of knowing those again those behaviors. So the real definition precise, a factory centralizes object creation decisions based on runtime information, not convenience, not syntax, decision ownership. What it is usually used for, this answers your big confusion. You ask UI, services, policies, Boolean behavior. Correct answer. Factory is used when the choice of behavior depends on runtime context. So it is being used. It can be in UI, it can be in policies, and it can be in behavior. So basically, it is using prototype. So if that prototype depends on a runtime context, you would use like a factory. Common real-world uses: first, authentication systems, create guest user, patient user, doctor user, admin user. Second, payment providers, create PayPal processor, Stripe processor, Gcash processor. Third, messaging, create SMS sender, email sender, push sender. Fourth, real-time sessions. You're up, create waiting room session, active consultation session, observer session. This is exactly your live kit architecture. So this waiting room session, active consultation session, or the creation of these objects, as you notice, it's still all of them are constructor, though it might not be intuitive, especially for SMS sender, then PayPal processor, and then guest user for authentication system, and for waiting room session, it looks like it is a constructor, but because of what it actually do, or it actually acts on something, you might not think of it as a factory method, but rather a prototype. But it's not actually a prototype pattern. You already need a factory, you just haven't named it yet. So what you are currently doing without noticing, right now your logic probably exists scattered like if role is equal to doctor dot dot dot, and then if role equal patient dot dot dot, then if role equal admin dot dot dot. This is the pre-factory stage of a system. Factory replaces conditional logic with polymorphism. So without a factory, you would have this if logic. So instead of if user dot role equal doctor allow moderation, you do session dot can moderate. The behavior lives inside the object created by the factory. So it is like another way of thinking is that it's like a creator, a concrete creator tapping to a creator, or a behavior lives inside an object created by factory instead of attaching that behavior to the actual role or identity. Now you see why factory connects to prototype. Factory chooses the object. Prototype gives the object its behavior. So aside from like singleton relation to factory, prototype is also highly related to factory, because a factory chooses the object, and then the prototype gives the object its behavior. So factory basically chooses the object that you can import, or you can tap from the creator using concrete creator, and the prototypes give the object its like local behavior. So where your understanding is hand wavy, here are your current imprecisions. Misunderstanding 1: you think factory is about creating many objects easily. No, it's about removing knowledge of concrete types from the caller. I think there's also a concrete, yeah. So in TypeScript, there is a concept of concrete type. Like most of the basic of TypeScript, you would define the types concretely instead of like allowing any types, or allowing any type argument to be an any type. So usually you study the basic using a concrete type. Here you can think of a factory. It's about removing the knowledge of concrete types from the caller. Or the another way of thinking about is that removing the knowledge of the concrete creator. I mean, having the creator not know about the concrete creator. So it's depending on the concrete creator how it will tailor the locality of its behavior, whether for creation of guest mode, creation of session, or creation of payment, or creation of message. So the caller should not know class names or the constructor of that object where you reference to. You basically just invoke that using concrete creator. Misunderstanding 2: you're missing permissions with state flags. So you can authenticate, can join room, can send message, can moderate. Right now you are treating these as properties. They are not properties, they are behaviors determined by the kind of participant. So this actually not properties by the object that you would attach to execute this behavior, but rather determined by a kind of participant. So you basically use like a a policy way of coding rather than state flag, which means they belong to different objects, not one object. Factory is exactly the mechanism that chooses that object. So here, it's kind think of this. You may think factory again is an identity, but not. It can also be this different type of behavior, such as can authenticate, can join room, send message. So think about this as a method that can be invoked by a concrete creator, or they belong to a different objects, not one objects, because different objects, depending on their locality or behavior that they will implement in their local, can invoke this. So factor is exactly the mechanism that chooses that object. So the factory method is what allows you to be able to like create this, and then have the concrete creator invoke this, and then the concrete creator will then create its concrete product depending on its local implementation, and will now return the product. Misunderstanding 3: you think patterns are about code organization. They're actually about responsibility placement. Design pattern answer which part of the system is allowed to make decisions. Factory says only one place decides what something is. So another thing or way of looking at it is that those pattern allows you to know which place are responsible for placing something, such as those creator. So those creator decide who can invoke those and how it will be invoked to be able to use by the local behavior for their local use. So the big subtle misunderstanding that will block you later, here it is. you're still modeling your system as one user object plus many conditional permissions. So, but it's a large implementation. It's not as um, it's not as divided, or rather it's not as yeah, it might be a deep module, but it's actually not as modular as like removing that responsibility from that object and allowing the factory to abstract it from that. So that's actually more capable of removing complexity than one deep module. So you may think that this one deep module always applicable, but this is the case where it's not applicable. But scalable systems model as many kinds of participants with different behavior. But scalable systems model as many kinds of participants with different behavior. This is difference between authorization system and the main model. Your teleconsulting consultation app is a domain model problem, not a permission problem. So how factory connects to TypeScript? Important clarification. TypeScript was not invented because of factories or prototypes. It was invented because JavaScript lacks compile time guarantees. So TypeScript were not invented because of this factory and the prototype pattern we discussed previously. It is because of the compile time guarantees. However, and this is subtle, TypeScript works extremely well with factory because of interfaces. Example, so in the future video we will discuss how this interface language feature of TypeScript works. So interface participant session with a key value can join room, and then with a key can join room and a boolean value. So for interface, kind of like an object, it can be an object, and an object usually has a string key, unlike with I think array needs to have a number key. So here can message is a function with a key with a value boolean, then can moderate, and then factory returns doctor session, patient session, observer session. So as you can see, this participant session is the creator, and then you have this multiple methods that you can invoke using a concrete creator. So here it will return this factory will return using its concrete creator based on the doctor session, patient session, or server session. As you can see, these are again a prototype or behavior contacting each other. All satisfy the interface. This is called programming to a contract instead of a concrete type. So because you don't know the type ahead of time, you program based on contract. Like this is the allowed methods for this, and then based on runtime, the people that calls this will call this, and this respective type will depend those local type and local behavior. So programming to a contract instead of a concrete type. That is why factories appear everywhere in backend and large React apps. So the clear mental model you should keep. Here's the simplest precise explanation you can remember. Prototype shares behavior. Singleton controls instant count. Factory decides identity. And together they form how objects come into existence, how many exist, and what they can do. The final essence, factory exists because in real software, behavior must depend on runtime reality, not compile time assumptions. Your live kit system cannot know ahead of time who is joining consultation. So the system must first inspect context, token, role, session state. Second, choose an appropriate participant object. Third, return an object whose behavior matches reality. The three-step process is the factory pattern. If prototype taught you object share behavior, factory teaches you object represents roles in a system. So again, that's another great description. Factory teaches you objects represents roles in system. And that realization is usually the point where developers stop writing permission checks everywhere and start designing architectures. Good. This is now the real software architecture question, not a pattern memorization question anymore. You're no longer asking what is a factory, you're asking how do singleton, prototype, factory connect to real structure of an application, like my life kit up, and especially to policy, permissions, hooks, services, and TypeScript. That is exactly the moment where many developers stall because books explain patterns as object creation tricks, but modern JavaScript systems, React plus Node plus TS, use them as ways to control complexity and change. So let's rebuild the whole mental model from the ground up, and I'll point out your subtle misunderstanding along the way. First, the most important correction. You currently think patterns are mostly about objects and classes. This is the biggest hidden mistake. Patterns are not about objects. They are about where decisions live in a system. Creation patterns, singleton, factory, prototype are actually answering one question. Who is allowed to decide what is this thing actually is? Not how to code it, not syntax, authority. Software architecture is authority management. Why singleton existed and why C++ cared? The sentence you quoted earlier. Deferring execution isolates from unpredictable dynamic initialization order. So this is with singleton. This is a very C++ problem. In C++, logger, semicolon, which is file A, database db, semicolon, which is file B, you don't control which is created first. If db uses logger in its constructor, it will crash. Singleton solves this by delaying creation until first use, like logger and getLogger function. Inside is a static logger instance, semicolon, which means created only when called, and then return instance, semicolon, then closing semi-curly bracket. So notice is the real purpose, not one object, but control initialization timing. So singleton is actually a runtime creation authority. So again, another way of explaining singleton is it's a runtime creation authority. So it controls the initialization timing. Why JavaScript changed the conversation? JavaScript doesn't need singleton as much because export const logger equal new logger, open and close parenthesis, semicolon, or new logger function. Modules themselves are singletons. The module system already guarantees one instance. So when Adi Asmani warns, if you need singleton in JS, reconsider your design. He means you are trying to solve an authority problem using an object trick. Now the three capability models, this is the part you ask. You wrote, it's the policy here. Yes, this is not about prototypes anymore. This is architecture. There are three fundamentally different ways to model capability. First, state, data authority, user.permissions equal object. So inside object we have one key and value. Key can moderate, colon, true is the value, meaning the truth lives inside the object. Problem, the object now owns security. So this is the stale data or state flags way of initiating the object or instantiating the object. This is dangerous in distributed systems. Second behavior, object authority. So user that can moderate function. So now the object decides what it can do. This is classic OOP. So the object or the local implementation now decide based on its locality what it can do. But it still ties permission to the object's identity. Right? So third policy, system authority, what your app is moving forward. So we have policy that can moderate parameter user, comma, room. Now the system decide, not the object. This is huge because permission often depend on time, role, room state, session state, database, business rules. So because permission depend on many factors, you won't be able to know that in runtime. So it's better to attach that policy with this user and room object parameter. So permission often depend on time, role, room state, which is the room argument, sorry, room parameter, session state, database, business rules. So those in are related to user object. A user object cannot safely hold that. Where this appears in your LiveKit app, you actually already implemented it, ai-entitlement-policy.ts, then role-conflict.ts, then consulting-session-store.ts, then waiting-queue-slice.ts. These are policy objects. Your code can authenticate, can join room, can send message, can moderate. These are not object methods, they are authorization policies. You didn't realize it, but you moved from OOP, policy architecture, very advanced. So these are not object method, but rather authorization policies. So we're creating the object in a higher level in authorization policies. Now where factory enters, but remember, okay, this constructor usually are being used for an actual API, or you're actually creating something from scratch or a framework. But since my LiveKit app is kind of like doing that, I need to be able to use that type of constructor policy. So now where factory enters, factory is not about constructors. Factory answers who decide which implementation we use. Example in your app, firebase-factory.ts, then and rtc-transport-adapter.ts, and summary-service.ts. You don't directly do new Firebase admin function. You let something else create it. So you let concrete creator invoke it, because in production versus test versus local emulator, you need different objects. So factory is environment dependent creation. It protects your core logic from infrastructure. So it you can think of it like separating the service layer from the infrastructure. And prototype, the one you struggled with. Prototype is the most misunderstood pattern in JavaScript. You thought cloning objects? No, the essence is sharing behavior without copying state. JavaScript objects state is owned, methods shared. So the one that's owned is actually the actual state at a given time. A methods is usually shared. Is actually all over the place shared. Example, cons user equal an object with the key name and the value string Garrett, and then add a method via prototype. User.prototype that can send message equal function, and then inside the function is an object. Now 10,000 users share one behavior function. Each user has a different state. This is exactly the sentence. Behavior is shared, state is local, not philosophical, literal memory model. So why React loves this? React components, each render state equal unique, behavior equal reuse function logic. So the behavior were copy or reference to from the prototype, and the state is the unique for each component. Hooks, use session chat function, and then use waiting queue function. These are behavior modules applied to many local states. For hooks, the hooks, we have different kind of hooks. The hooks that allow us to like change or to substitute the class state cycle management. So here another way of looking at it is just a prototype that can be applied to many local state instead of a component that has a prototype that is applied to one particular state. So you were already using the idea, I just didn't have the language for it. Now the subtle misunderstanding you currently have, these matter because they will block senior level understanding later. Understanding 1, you think patterns are mainly objects. Reality, patterns are about system boundaries and decision ownership. Misunderstanding number 2, you think TypeScript pushes toward classes? No, TypeScript pushes toward structural typing, doc typing, meaning if it behaves like a session, it is a session. This aligns much more with factory plus policy plus composition. So TypeScript actually do not push toward classes just as JavaScript does. It pushes structural typing that aligns with actual the factory pattern we discussed, the policy pattern, and the composition in which you like creating a complex function based on smaller function, not inheritance hierarchies. So your intuition, TypeScript apps 80 to 90% prototype composition. Yes, is that essentially correct? So TypeScript app uses a prototype pattern and or composition, but for prototype it uses mostly a factory pattern because a factory is a prototype. Modern backend or front-end architecture is not a classic OOP. It is composition architecture, another misunderstanding. So for modern frameworks, they do not use a classic OOP like Java and C++. They use a composition architecture, or more of like a factory or prototype or a composition or policy. Misunderstanding 3. You think factory or prototype or singleton are about UI versus services. They are orthogonal. They can be used both. They are about pattern. They are about like for pattern, singleton controls lifetime. Pattern factory controls creation decision. Pattern prototype controls behavior sharing. Pattern policy controls permission decision. The deep essence, the one interviewers actually look for. All these patterns are solving one deeper problem: change without rewriting. Your life kit up, doctor, patients, admins, rooms, waiting queue, moderation. These roles will change. Patterns let you change who can join, who can chat, how sessions work, which is which backend provider, which AI service without rewriting the system. Why this matters? For your level, you're already doing mid-level work. What you're missing is not knowledge, it's the unifying mental model. Software architecture is not about objects, it's about separating data, behavior, or state, and then prototype, the creation factory, and the policy fourth authority. You accidentally already separated them in your app, which is why your design works. The pattern is simply names for the separation you already started building.